See, today we are going to discuss once again revising that bending beam. Okay. See, this is the beam. Okay. This is the beam, but uniform rectangular beam. Okay. Same thing I am drawing here. This is the beam part. M one end, another end. If you bend this like this, okay. If you see, are you able to see this one? If you bend like this, means it will come like this. Okay. So one side is fixed, other side you are bending means like this. It will be there. Before going to discuss this bending beam expression, just once again I am recalling that beam it is a uniform area of having the length is more than its lateral side. Such material is called as beam. Okay, types of beams and all these things is there. You go through that. What the I explained before that. So this beam I wrote here M and N. If you bend it, okay, there is a two chances to bend change this length. What the outer layer it is a extension, the inner layer it is a contraction. Therefore this is the elongation, this is the contraction. Same thing. See, a to b is changes, for example like this, for example like this okay. Take here picture like this okay. This is a b E F. This is C D. EAB means outer layer. EF means inner layer. If you bend means AB changes to E dash B dash. If EF changes to E dash F dash. And CD is not going to change. Therefore, this axis is called neutral axis. This axis is called as a neutral axis. This surface is called a neutral surface. The elongation surface is this. Okay, neutral contraction surface is this. So same thing I am going to bend now. Like see. Are you able to see here bending? Yeah. If you bend like this, it means it will become a circular. It will become a circular. Therefore, the from the neutral point and the at the origin, that is called the circle radius of this circle, like this. It is a drawing. Okay. So from one layer to another layer, it means neutral surface to another elongation part or contraction part. That is distance by r, small r. So these are the contraction. Now AB is extended to A dash B dash, EF is contraction to the E dash F dash, CD is not going to change, that is neutral surface, R is the radius of this. Now the arc divided by length, arc by length is called as a theta, or the shearing angle or common angle, you can say that. Theta is equal to arc by length. Length is what? Radius, the fundamental, CD by R. Are you able to see here? Yeah. So this is. Now what is the change of length? Change of length is AB dash minus AB. AB dash minus AB. Okay, that we know the change in length of this beam. But we know that without going to apply the force there, AB is equal to CD. The CD is equal to R theta. The same AB is equal to CD is equal to R theta. You write. If this beam is compressed the number of layers, one above the other, the layer to layer it is differentiate or distance between the small r. That same thing I written. The layers are separated by small r. Therefore, A dash B dash can be written as A dash B dash. AB is equal to R theta, but A dash B dash is equal to R plus R. Why I am changing R to R means it is separated by extra r, small r. Therefore, R plus small r into theta. This is there. Therefore, the net change of the length is equal to r plus r theta minus r theta. So r theta get cancelled. Therefore, small r theta is there. Therefore, you write. Okay. Once again, what is the original length now? Original length is r theta. What is the change of length here? Okay, change of length is what? Change of length is the small r theta. By using original dimensional, change of dimensional, we can write the strain. The linear strain can be written as change in strain by original strain. Change in strain is r theta, small r theta and capital R theta. So theta get cancelled, r by r. This is the strain, linear strain. Okay, length of strain. Now the Young's modulus can be written as, what is the formula for the fundamental? Longitudinal stress by linear strain. Then linear stress as it is, longitudinal stress by linear strain. This is the Young's modulus fundamental equation formula. So linear as it is, then cross multiply y into linear strain. Linear stress. Okay, linear stress into y. Linear stress is equal to y as it is. What is the linear strain? Linear strain is r by r. Therefore, stress is equal to linear stress is equal to y into r by small r by capital R. This is the equation, one standard equation we get. But we know the fundamental. What is the pressure or stress? Stress is the force per unit area. Once again I wrote the force per unit area. This is the stress, this is the formula for stress, coinciding both sides. Therefore F by A is equal to Y R by R. Though F is as it is, Y A it will come up, therefore Y R by R. This is the moment of force about the one layer. But you take the moment of inertia of its axis. Of its axis means it is separated, and this is multiplied or it is separated by a distance, or the moment of inertia, moment of force is equal to, about its axis is equal to force into its displacement, perpendicular distance, force into its perpendicular distance. Force as it is F you write, and distance is how much, R is there. Therefore F into R, F you write once again YAR by capital R into R. Therefore Y, this will becomes YAR square by R beta. But you know that, okay, what are the common things here? Young's modulus, you know, radius, you know, Young's modulus, radius you take, okay, radius of the beam, okay. Therefore A R square nothing but moment of inertia or radius of gyration. Sometime it will take K square. Are you able to hear? K square. Therefore moment of bending or moment of force can be written as this radius of gyration, summation of E R square can be also written as I, moment of inertia, that is Ig, along with its geometrical length. Ig is equal to I YR. Ig is what? MR square or ME square. Ig into Y. If in case of the rectangular, if it is a rectangular, then you write its area. The area of the rectangular is BD cube by 12. Then wherever Ig is there, the Ig is the area. Okay, what is the geographical status or geographical structure of this is rectangular bar. The rectangular bar area is BD cube by 12. So substitute the values. This is the moment of inertia for the rectangular cross section. If it is a circular, then you write its area pi rho to the power of 4 by 4. That will be circular, will be, that is moment of inertia for the circular, moment of force, sorry, bending force or moment of force can be written as circular means Y by R, okay, into pi rho by 4. Okay, Y pi rho to the power of 4 divided by R4. This is the circular. So this completes the equation of rectangular and circular case.